In late 2015, the regulators at the International Civil Aviation Organization came together to put additional restrictions on the air shipping of lithium batteries. One of the big restrictions that they put into place at that time was to limit all standalone lithium-ion cells and batteries being transported by air to a state of charge no more than 30% of its rated capacity. So what is state of charge? If you think of fuel tank, is the easiest way that I can relate to it, is you have the size of your fuel tank is, how many gallons of gasoline it can hold, and then the state of charge would be how much gas is left in the tank. So if you think about a lithium battery, the purpose of a lithium battery is to store energy and then release that energy in a controlled manner to power a laptop, to power a cell phone, to power your car, whatever the case may be. The good thing about lithium batteries is that they hold a lot of energy, so they're extremely energy dense. So that's awesome because now you can drive your car 300 miles on a lithium battery. That's fantastic. The downside is in extremely, extremely rare cases, batteries can fail and go into thermal runaway. So thermal runaway typically is going to consist of extreme heat, fire, projectiles, off gas, depending on the battery design and the chemistry. Lithium battery thermal runaways can be really, really nasty, really, really dangerous. So the thought here is with the state of charge is if the purpose of the battery is to store energy and a thermal runaway event is basically an uncontrolled release of energy, if you have less energy in the battery, if things go wrong, you're going to have a less volatile reaction. So you might have a battery, lithium-ion battery, that is fully charged. We would call that 100% SOC or 100% state of charge. If that battery were to fail, you're going to get most likely some pretty intense heat, flames. So it's not necessarily a linear scale, right? But through test data, through tests that have been conducted for the last decade, it's very clear that batteries at 30% state of charge are going to be less volatile, less hazardous than a battery at full state of charge. So then the question becomes, why 30%? What we would be, happy to say is that 30% is not necessarily some magic safety number, right? 30% was arrived at through negotiation between the regulators and the battery industry, right? So if you think of, again, batteries having energy and the energy is cause for some of the hazard during a thermal runaway, regulators would say, why don't you ship them at 0% state of charge? And while that would be great for safety, the problem is when you keep lithium batteries at low state of charge for long periods of time, it significantly reduces the battery's performance. So, if you think about the regulators probably starting at 0 and kind of going up from there, it was ultimately agreed upon by both parties that 30% was an acceptable safety factor to the point where it's going to mitigate risk of thermal runaway, because again, if the battery goes to thermal runaway at less than 30% state of charge, you wouldn't necessarily expect a catastrophic reaction, but it also balances the industry need of keeping batteries at 30% is not necessarily something that's going to harm the performance of that battery long term. So that was sort of the balancing act that between the regulators, between industry, that was adopted, kind of put into the books in early 2016. So it's been about 9 years. The initial period of early 2016 was difficult because state of charge is relatively straightforward in terms of controlling. If you are the battery manufacturer, you assemble or you manufacture the battery and you're in control of the state of charge. But as batteries go out through the supply chain and they're going to end users, they're going to their applications, it gets increasingly difficult to know the state of charge on any given battery. And there's also really not simple ways to measure state of charge. You can't really go on Amazon and buy a device that's going to measure the state of charge on any lithium-ion cell or battery. That doesn't exist. So in the best cases, you might have like a little LED indicator light on a spare battery that'll tell you, maybe if all 4 lights light up, then it's at 100%. If only one of them lights up, you might be kind of thinking that it's probably 25%, which is obviously less than 30. But that's even rare that batteries have those indicator lights. So Oftentimes, it would require people plugging batteries back into the equipment they power and hoping that equipment would give them a readout of what the state of charge is. Or most commonly, it requires a reconfiguration of supply chain. So the way that people got into compliance with the 30% state of charge, by and large, it's not for everybody, but the main way that it happened was starting at the source. So if the original cell manufacturer made sure that they sold you that cell at no more than 30%, then you can put that cell into a battery pack. And if you don't charge that battery pack, it's still going to be equal to or less than 30%. And then by the time it hits a distribution center or warehouse, again, if you're not charging it up anywhere along the supply chain, you know with pretty good certainty that when you go to ship that battery out to a customer, that it's going to be at less than 30%. So that's the typical chain that it works now. Obviously, it took a while to adjust, and during that period of adjustment, there are a lot of companies that just didn't ship their lithium-ion batteries by air because the hurdle was too great in terms of controlling state of charge and some of the additional regulations. So fortunately, the industry has adjusted. We're also seeing some of these state of charge restrictions or guidelines kind of creep into other areas, including storage of lithium batteries. There's new fire codes as of last year, and part of the fire codes standards are that there are some reductions in terms of risk mitigation if you can keep all of your batteries in storage to less than 30% state of charge. So this is also coming into 2025. I should probably remind some of the viewers that there are new restrictions on lithium-ion batteries packed with and contained in equipment. So the state of charge restriction originally was assigned to only standalone lithium-ion batteries, so UN3480 for those that do dangerous goods. Starting in 2025, there's now a recommendation from the regulators that when you have your lithium batteries packed with the equipment they power or contained in the equipment they power, like a laptop or a cell phone, it is recommended starting 2025 that those batteries are at no more than 30%. Moving into 2026, it's going to be mandatory that lithium-ion batteries packed with equipment be at no more than 30% state of charge. So there is a difference between packed with equipment and contained in equipment. Lithium-ion batteries packed with equipment, the easiest example would be like a power drill, where you might have a kit with a power drill and then one or two spare batteries inside of that same kit. That's a classic example of packed with equipment, and that that configuration starting next year, January 1st, 2026, you're going to need to ensure that all of the lithium-ion batteries in that kit are at no more than 30% state of charge. Moving into 2026, when you have lithium batteries contained in equipment, so a laptop or a cell phone being the obvious examples, those it is expected to remain a recommendation. So that could be something in the future that the regulators, they kind of look back on and see if maybe they should extend that requirement to contained in equipment. They have not done it yet, but we will see into the future here indefinitely that there is going to be that recommendation even on lithium batteries contained in equipment. It is also extremely difficult to enforce this. So if you're a DOT inspector or an FAA agent, as I discussed earlier, there's not really a tool that you can go by and touch a battery and it's going to magically tell you the state of charge of that battery. Those tools they just do not exist, right? So if you're in the enforcement process, it's really difficult if you're looking at packages and batteries to know what the state of charge of the battery is in there. So the best way that I work with my clients when talking about enforcement is if I were to put an FAA hat on and try to enforce the 30% restriction, what I would do is I would ask the shippers, the companies, to say, number one, we understand you ship lithium-ion batteries by air. Tell me how you keep your batteries at less than 30% state of charge. You need to have an answer to that question. The 30% state of charge restriction is best thought of, at least by me, as just an additional safety factor. So if I'm shipping lithium batteries by air or by any transport mode, there are already regulations on how to properly package the battery. So there are, kind of language around making sure the battery is completely enclosed in some type of inner packaging, preventing short circuit of the battery, also making sure that the battery is kind of packed securely within the box so it won't be bouncing around and getting damaged. So there's really restrictive packaging requirements in terms of what outer box you need to use to keep that battery safe during transport. There's also requirements for package labeling to communicate to emergency responders and package handlers that lithium batteries are present. And then in some instances, there are requirements to fill out additional paperwork for shipments of lithium batteries. So those, from the dangerous goods side, in terms of packaging and hazard communication, those rules have been in place for many years. And so it's best to think of the state of charge restriction is adding on top of the existing packaging and hazard communication regulations. So we already have our baseline regulations about preventing the battery from short circuiting or from damage during transport. And then the 30% kind of just adds on top of it to say, well, if there is something, there's something goes wrong, the battery was damaged, maybe the battery has some type of defect, that even if the battery goes to thermal runaway, we know that it's going to be at less than 30% state of charge. And the key with that is most, and I have not done all of the test data in the world, or I've not reviewed all the test data in the world, but most lithium ion batteries, when they're at less than 30% state of charge, will not generate enough heat to propagate the reaction to other cells and batteries. And this is really important. So nobody wants a thermal runaway to happen with a battery on an aircraft, on a truck, on an ocean vessel, or anywhere ever. But these things do happen. And so what we need to understand is something like the 30% restriction won't necessarily stop thermal runaways from happening, but hopefully the idea is that it'll prevent some type of catastrophic fire where one battery goes to thermal runaway, the heat from that battery sets off the other 300 batteries in the pallet to go to thermal runaway, and now you have a catastrophic fire. So that's ultimately what we want to prevent.